All right, in this video, I'm just going to go over some basic ideas of functions. They're called toolkit functions. Um, just so that whenever you see the, uh, the variables of a function, you'll have some idea of what it looks like in a graph so that you'll be able to tell just when you see it what kind of what what the formula looks like for that graph. Okay? So first off, let's look at this one. Just a straight horizontal line. That means that no matter what the input is, you're always getting the same output. Same output every time. Go out to infinity, output is going to be 1. It's a positive number, we know that, because it's not on the x-axis itself. That is called a constant function. And we represent it by saying f of x equals c. And c could be anything, but usually it's just a number, f of x equals 1 in this case. I'm like, where's the x in f of x? No, there is no x in f of x. That's why it's a constant function. See what I mean? All right, let's go to this one. I didn't really draw this very well. That is supposed to go through the origin point there. This is just a diagonal line, right? This is called the identity function. We call it that because it's just f of x equals x. So any function that you see that just has an x in it anywhere, whether it's being multiplied by something or something added to it or subtracted from it, you're going to have a line somehow. It could be going down as we go from left to right. It could be going down, or like this, it could be going up, but it's going to be a line. That's called identity function. Now, what do you suppose this is? How did we get a perfectly straight line, but then when it hits 0, it goes and goes up the other way? Well, kind of like this one, only something happens to keep it from being negative, keep the output from being negative. See, there's no negative outputs. That's because it's an absolute value equation. You ever get an equation that looks like that, then you know it's an absolute value equation. If you ever see a formula with an absolute value in it, you're going to get a V-shaped thing. Now, there could be a negative in front of it. If you get f of x equals negative absolute value, then the output will always be negative. See that? Because whatever you input, that will be positive, but then it's going to get multiplied by -1 and always be negative. See how that works? So whenever you see a V shape, whether it's going down or up, think absolute value. All right, let's look at this one. We deal with this one quite a lot, right? It's a parabola. So what does f of x equal? X squared. And that is called, not parabola, but quadratic equation. I don't know why they call it quadratic equation, because quad means 4, right? But just try and memorize all these. Remember, quadratic, because there's a 2 there. If you're taking your x and you're squaring it, multiplying it by itself, you're going to get a parabola. Same kind of principle. Your output is never going to be negative, just like the absolute value, right? but instead of it being two straight lines, it's curved and it kind of gets steeper and steeper, and the slope changes constantly, actually, as you go up and up and up. All right, what about this one? I was doing a little dance there, kind of like disco. This one is similar to quadratic, but instead of squaring our x value, we're cubing it, so it's a cubic equation. All right, so now you know if your graph is kind of curving and doing a disco dance, it's cubic. If it repeats the disco dance and it has asymptotes, that's a whole other thing. That's a trig. What about this one? This is crazy. What the? We get so close to zero, but we can't quite get there. And then, whoa, suddenly our outputs can't be positive and they're always negative. What is going on there? That is called, oh, I was going to do the function, the formula first, but let's write the word first. Reciprocal. And I need to spell reciprocal correctly. This is a reciprocal function, which means f of x equals 1 over x. Does it make sense now? You put your input in there, a really high input, you're going to get a really low output because your x, your input, is your denominator in this case. So 1 over 1,000 is a very, very small piece of the pie. So the larger your denominator is, the smaller the number. However, we take that up here, we get our output is like 2, and then it's only 1/2. So then it's like that, 1/2 of 1 is your output. Then if it's 1, then your output is 1. And if it's less than 1, then suddenly your output starts skyrocketing, right? Because if you're dividing 1 divided by, say, 0.05, you're actually multiplying it by 50. So your output value gets really, 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 really big, really fast, as closer you get to 0. But can your x be 0? No, it can't be 0. So you draw a dotted line here. That's an asymptote because x cannot be 0. But eventually we get over 0 and we get to the other side and it's negative, right? Your input is a negative number, and suddenly your output is really, really, really small. And then when you get to -1 finally, then your output is also -1, and then as your input gets smaller and smaller and smaller, then your output gets closer and closer to 0. It actually gets larger, but it just can't quite get there. It slows down though. It gets because it can't hit 0 either. So your output is kind of like an asymptote in itself. It's interesting. Anyways, that's a reciprocal function. What's this one? Our output is just never negative. So what is happening here? This is the brother of reciprocal. This is reciprocal squared. Whoa. So we do f of x equals 1 over x squared. Suddenly, our output, even if or input actually, even if our input is negative, like -2, it's going to get squared, which means it's going to be positive. So our output will always be positive. Make sense? So that's reciprocal squared. It looks kind of like reciprocal, but always positive. My output is always positive. Of course, your input could always be negative. Now, what the heck happened here? We start at 0, but it never goes anywhere else? How does that work? Well, this is the square root function, represented by f of x equals square root of x, right? As x gets larger, it kind of slows down. So it doesn't curve and get steeper, it curves and gets less steep, right? Because you get to, 9, square root of 9 is 3, right? You only go up 3. And then you get to 81, square root of 81 is 9. So you're only up to here. Square root of 121, you're only, that's 11. You're only up that far, So that's why it levels out. Now, if you get kind of the square root function, but it keeps going, that means you got a cube root function. That's a cubic function. This is cube root. Now, see the difference here? If your input is negative, what happens? Imaginary numbers happen. That's why this graph stops at the origin. X equals 0, output is 0. X goes negative, nothing happens. There's nothing there. It's imaginary numbers. Cube root doesn't do that. You put a negative in there, you still get you get a negative output because you multiply a negative by itself 3 times, you'll still get a negative out. That's why it works for cube root. And cube root will get less steep faster. That's the only difference with that slope change there. It'll just get steep or less steep faster. So those are the toolkit functions. That's it. And we just want to memorize what they look like and the words that go with them. So take a picture of that.